Hey Imaad,
Hello.
welcome.
Hey, hi. So I guess we all are here now. Let's get started with our today's event. So welcome again all for our Pi and AI Bangalore meetup, which is being hosted by NeuralMinds Data Science Club in partnership with deeplearning.ai. And we have a special thanks to Indegene for helping us making this event happen, right? So for our event, the theme what we have for today is journey into the data science. So we have all know that in today's date, data is the new oil, and we are all aware that it takes either a researcher, scientist, or an analyst to make work with the data, do all the number crunching and data manipulation to build the algorithms and models, which makes the data actually works for you, right? So in this session, we will be mostly exploring into what it takes and what it makes a data to work, and how you as a data scientist or a data science team can upstream or enhance your current systems, or in short makes your unstructured or dark data more valuable. So this session will brief you into what are the ways, what are the steps data scientist goes through in making the data work. So before we get started, I would like to share a video what we have received. So we have a video of Dr. Andrew Ng, which deeplearning.team has sent us to inspire and motivate the deep learners here with the community initiatives they are taking. So let's have a look into the video before we get started into the sessions.
Hello, deep learners. I'm Andrew, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so we can see where it all happens. Oh, hi, Andrew. Do you want to tell our friends at Pi AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having. Today, I'm putting together the next issue of Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's the most surprising thing you've run into working on the Batch?
How much is going on in this field? There is never a dull moment. You might think from the outside that machine learning engineers understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together.
All right, I know you're ready to see, so let's get back to it.
Thanks. See you later.
Let's go meet Ken, who we created deep learning specialization. He's working on an exciting new project. Hey Ken, so you are the people at Pi AI, what you're working on?
Yes, sure. I'm leading a project with Martera, focusing on yes, offers AI that needs to be verified testing their skills, reporting to teams, exercising them, as well as launching and referring them to good jobs.
That's really cool. And what's the most exciting part of your day?
The AI field is new, organizations and jobs are misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what processes we work on, and what skills are needed to achieve these tasks.
That's really cool. That's nice job. And now let's go chat to
create AI education content accessible to people who are in the people like you. I'm so excited to see everybody and to see how
Yeah, so that's it for the video. So I hope you found that video insightful. And interestingly, as Dr. Andrew highlighted, right? So it's all about working with the latest research and replicating the paper. So we ourselves upskills and see how well the research is enhancing and what do we need to serve our business requirements and the data, right? So without further delay, let us get started. So myself, Swhoami, I'm the organizer for this event. Along with me, I have my colleagues Adarsha and Prateek. Thanks for making this event happen. And for our today's talk, we have our speaker, Mr. Imaad Mohammed Khan. So to give you an introduction about Imaad, Imaad is currently working as a data scientist for a company Vahan.inc, and they are mostly working into the space of AI and helping people get a job through the AI platform. And prior to this, Imaad was a co-founder and a CTO of his startup, which is called Recreate.ai. And previous to that, Imaad was a data scientist in Indegene, where he worked on various different NLP applications. So without further delay, let me hand over the session to Imaad. Imaad, are you there?
Yes, Swam. Thank you. I think I will need your help as well in controlling the presentations.
Sure, no problem. So I guess, have you emailed me?
Yes, I have sent it to you.
Okay, let me just check it out. Just bear with me, guys. I am getting the presentation ready.
Swam, don't tell me that you're making the presentation now.
No, just downloading it, right?
Kidding. Yeah, it's funny the situation right now. I mean, I can maybe in the meantime talk a little bit about how the situation has come about. I was initially trying to get started with GoToMeeting on my laptop, but it wasn't allowing me because of the system requirements. So it says my OS is not supported, unfortunately, which is strange. So
Yeah,
that's
these are
yeah.
the connectivity requirements for the
Yeah.
platforms. Right, I'm just waiting for the email to arrive.
Oh, okay, let me check if you. I think it should. Okay, let me resend it if it's not there, so that
Yeah, please.
because it should have been And I think I sent it again now, if in case.
Okay, I'm just refreshing.
Yeah.
Yeah, I guess we see this time. Yeah. Okay. I guess you are using an Ubuntu, right?
Yeah.
Yeah, that's why the network doesn't allow Ubuntu to make you as a presenter.
Yeah. Anyway.
Sure, just a second. Yep, I think we are ready. Let me share the screen.
Sure.
I hope my screen is visible.
Yeah, I can see your screen.
Okay.
You can go into present mode, and maybe I can just say that, yeah, change of slide or next slide, and then you can just change. Yeah.
Sure. Let me just make it full screen.
Sure.
Yes, please.
Sure. Thank you, Swam. Thank you so much, NeuralMinds team, Indegene team, for having me speak today. I think I got a little bit of a brief or a little bit of information from Adarsh and Swam that maybe you can talk about an overview of how things work in the industry. And they said you can call it journey into data science. I thought journey into data science would be a more beginner topic in the sense that you are more trying to see how you can get into the field in itself. So I thought data science safari would be much more appropriate a title because of the jungle that data science is and a lot of trees that you will implement and you will have to cut and go ahead while implementing projects, right? So that's why I renamed the topic a little bit. So yeah, that's more about the topic. We can go ahead. A little bit about who I am. I think yeah, so I am give a small introduction, but I think this helps to set some context. I work as a data scientist at Vahan.ai. We help low-wage or blue-collar workers find jobs using WhatsApp. Prior to this, I was co-founder and CTO at Recreate.ai, where we were trying to build uh, a system which could automatically convert text to videos. I am also founder at Mantis Data Science, which is something which is another data science community that I run. So in fact, we have another meetup right after this. So if you want to join that, you can let me know. Data scientist at Indegene previously, and that's where I interacted with a lot of these folks. So I know all of them personally. So that's how I think I got the invite, or else I wouldn't have got. So that, yeah, and I did my master's in Internet Technologies and Information Systems from TU Braunschweig in Germany. That's where I moved more towards data science, and yeah, that's how my transition happened from being an electronics engineer who graduated from Ramaya. Yeah, that's a little bit about me. I think with that said, let's get started with the agenda. So this is the agenda for today. I'll be talking about how can you actually get started, and then we'll look into who is a data scientist and what do people commonly think of when data scientist is referred. Then we'll see a few tools that data scientists actually interact with. This will help you understand maybe the day-to-day life of a data scientist, or basically what you need to actually work as a data scientist. And then we'll go through life cycle of a data science project, which is essentially how do you start a project, in an industry setting, and what are the different stages that you go through before you can say that you have finished your project. A little bit on team dynamics. This is something that I have not talked about a lot, but I thought would be interesting to share on. I mean, this is more as you go further in the organization, this becomes more important because then you are actually taking care of a team, right? So that's where team dynamics comes into play. But I thought one or two slides of this would be very useful for getting the entire context. And then we'll have a few questions and answers at the end. So that's the agenda. Getting started. Maybe we can move on to the next slide. Yeah, so this is you, or this is me, or anybody else looking into get into the field. And the problem is you. So now think of somebody who doesn't know anything about the field and have gotten some interest into the field because a lot of people are talking about it and see a lot of interesting applications being developed, but you have no idea what to do. So this is where you start off initially. I mean, everybody who is working in this field has started off at this stage, right? It might seem impossible at this moment, like to even think, like for example, Swhoami showed the video of Professor Andrew Ng, to even think of him not knowing what deep learning is, or him not knowing what he's doing. I mean, him not knowing anything about machine learning. It doesn't cross our minds at all. But everybody starts at this stage, and how you go ahead is by doing multiple things. By again, I have talked about this in many meetups and many places, but I'll just repeat here so that everybody gets context. So how do you go about getting started is uh, twofold. You start with a project idea in your mind, so something you want to really build, or you can do it the other way, where you say that, okay, I'm going to learn the math, I'm going to learn the theory behind all of this, and then basically learn everything there is about this field, and then get started with implementing in code and building projects. I think the second approach doesn't work because simply because there is so much theory that you will take like your lifetime to even get through the entire theory, right? So the best way, in my opinion, is to balance both your practical applications and the theoretical foundations that you are building on. So let's say we will go through an example, but let's say you want to build a text classification system which allows you to put incoming messages in different categories. So now that's a problem statement that you have, but you don't know how to go about it. And then you start breaking down the problem into small pieces that will allow you to, okay, now you need a text classification system. How can you do it? Okay, maybe you could write rules for that, right? You can say that, okay, this is what I'm going to do. But then you realize very quickly that rules are not going to work out. Maybe you need to do some machine learning, do some modeling. And to do some modeling, what model should I use? Now you go and refer to the theory about what kind of models have been used to do this kind of an application, right? And then dive deeper into what essentially is going behind the scenes of that model or algorithm. And this is how I think you can have a structured way of going forward when you're just getting started. Of course, as you go further, you will also need to beef up on your theory. But then if you want to just get started, I think this is one good way. And this is how I recommend to most people to get started. So this is how, right now, if you don't know anything, what you should be doing, you should be trying to think of a project idea and think of relevant theory for that, and then take both of them together simultaneously. Largely think of something you want to build and then refer to the theory that is relevant for that. Keep doing this in different areas, and then you will build a lot of skill set that way. So this is for somebody who's just getting started. We can move on and see who's a data scientist. This is Drew Conway's Venn diagram, very popular Venn diagram that a lot of people refer to describe a data scientist. So he essentially says that you need to have a combination of multiple skills, and data science essentially is an interdisciplinary skill. That's why you see data scientists from a lot of different backgrounds as well, and not all data scientists work similarly. If you look at this, if you have hacking skills, math and statistics knowledge, substantive expertise, the intersection of all these three sets is data science, according to the Venn diagram. So what do you mean by hacking skills here is essentially you having the ability to work with a computer, manipulate data, or anything else, right? Even reading a file or writing something to a file, or reading a database, inserting something in a database, managing programming a computer, or all these things, which whatever you got to do with a computer are essentially your hacking skills. How quickly can you build something in software, mostly here in this case, using a computer. Math and statistics knowledge. This is also very important for you to have a combination of these two. If you see, it says hacking skills and math and statistics knowledge will give you machine learning, which is more driven by the application of statistical learning methods. So that's why the hacking skills overlaps with the math and statistics knowledge. Math and statistics knowledge, basic introduction in probability and statistics, linear algebra, calculus, and I think these are the broad overarching mathematical fields that you need to have an idea on. Statistical knowledge, of course, I mean, there's a lot of debate between whether statistics is part of math or not, and all of that, and a lot of people have their opinions. But statistics in itself has a lot of different subsections. So all of that would, I think, be under the data science Venn diagram. And substantial expertise, this is where a lot of people like to call it domain knowledge as well. Like if you're working in different fields, if you have a certain insight about the kind of processes that happen in that particular domain, I think that would be very useful, right? Like, for example, Indegene itself works with a lot of pharmaceutical data, and pharmaceutical data requires you to have context about what you're actually doing. The same goes with medical data as well, right? If you do not have context, you might model the wrong things. So you need to be able to get the domain expertise there. And that's where I think if you have a combination of hacking skills and math and statistics knowledge is solid, and then you have some expertise in a particular domain, and that's where you start really shining as a data scientist, right? Then you start becoming, you start differentiating yourself, because a lot of people who want to get in the field have some of these things, but not all of these things. If it's a fresher trying to enter the field, they are likely to not have substantial expertise. If it's a math graduate, they are not likely to have hacking skills. If it's an experienced guy working, let's say, again, as a doctor, it's a vague example, but let's say he was working as a doctor, but now he wants to move into this field. He has a lot of this substantive experience that you're looking for, but not a lot of hacking skills and math and statistics knowledge. So, and therefore, that's why I said it's an interdisciplinary field where you can basically come from a lot of different domains and different areas and pick up skills on the other bits that are missing. So this is what a data scientist is. There is no one fixed definition. It's a combination of multiple skill sets, and this is how essentially now let's going back to the journey of you as a person, getting to know of the field, starting building projects, and now you know that okay, as a data scientist, you're supposed to have minimum of these things. So now your current state after this slide is, now that you've done a few projects, you've also seen what data scientist essentially is. Here's another introduction on what the kind of tools that you can use to do the projects. So going further, so this is how a data scientist, or not how, this is rather what a data scientist interacts with on a daily basis, sometimes on in general, you're supposed to know a lot of these things. So, like I said earlier, in the case of mathematics, linear algebra, calculus, probability, and statistics are, I think, basic required skills that you need to be able to build your statistical models or mathematical models on top of. Programming languages, a lot of data scientists work with Python, some of them work with R, SQL, some in MATLAB. I think Andrew and G's courses initially were in MATLAB, I think in Octave and MATLAB. So, and this is not exhaustive. Programming languages, a lot of people work with a lot of different languages. I think I've seen some people work even with JavaScript, but not as a professional data scientist. But there is a lot of effort towards pushing models in JavaScript so that you can render it on the web. So maybe you are a web developer working with models, right? So different languages, databases, MySQL, PostgreSQL, MongoDB, Neo4j. All these are different kinds of databases that a data scientist should know how to interact with, either insert data, create tables, delete records, all of that, basically all the CRUD operations, create, read, update, delete operations. Different databases have different kinds of requirements, different kinds of functionalities. So there are relational databases, there are NoSQL database, MongoDB is a NoSQL database, Neo4j is a graph database. So there are different ways of representing data as well. And I think once you start looking deeper into it, you will see that these are like different thought processes or different ideas about how you want to represent your data. And a lot of this, like the most traditional and the most the most traditional and the most widely used database in the industry, databases in the industry are relational databases. MySQL, PostgreSQL, and SQLite is not really used in the industry, but yeah, it's used for prototyping. But then uh, the shift, there has been a shift in the last few years towards using NoSQL databases and graph databases. So that's where you see databases like MongoDB and Neo4j, where you store data in a different format. And as a data scientist, you need to be able to move across databases and not be like a particular database specialist data scientist, and because that would be a disaster, right? If somebody tells you that tomorrow we're going to start using GraphDB and you've never used GraphDB in your life before, you say, no, I know only relational DB and I work only with relational DB. I don't think that is something that your management would appreciate and your colleagues would appreciate, because you have to adapt to the changing circumstances and not the other way around. So that is about databases. Data scientists also work with data visualization tools. So I put out BI tools over here. These are usually uh, tools used by data analysts, BI analysts, data scientists also use them. So Power BI, Tableau, ThoughtSpot, etc., etc. But I think a lot of data scientists do data visualizations, but not with these tools. They primarily use the programming language itself that they're working with. R has fantastic packages for visualization. Python also has a good ecosystem of visualization packages. So I think uh, data scientists would use those rather than these. But again, these are something that you can also work on, right? Like if it's something that makes your work easier and quicker, and you have licenses in your company, then why not? IDEs, uh, some of them, I mean, there's a lot of talk about what IDEs are best for doing data science. What should I actually use? Some people say they love their Vim environment and they will never come out of it. But there are a lot of different opinions on this. I've listed some of the most popular ones, like Jupyter Notebook or Jupyter Lab. Essentially, I think uh, this is a product by the Anaconda company, and used a lot by people who want to quickly prototype something, experiment something, and also write text along with some code. So Jupyter Notebook or Lab helps there. And there is Spider, which which is very similar to RStudio, which you'll see later, which is the Python version of RStudio. And Spider also allows you to have a screen for interactive, what's it called? Yeah, interactive REPL. So you can do that also in Spider. PyCharm is a product by JetBrains. PyCharm is, I mean, it's a full-fledged Python IDE, a lot of features in it, but it's also sort of heavy, like because it has a lot of features, it consumes a lot of RAM. So this is another IDE that you could use. RStudio is another, like I said, it's very similar to Spider. You have a lot of REPL, and a lot of people who work with R actually use RStudio and VS Code, which is also very popular amongst developers mainly. So these are the different kinds of IDs you would be interacting with if you were to work as a data scientist. And finally, I put web technologies. Your role wouldn't primarily be to work with web technology or develop web technologies, but then an understanding of web technologies will help you understand what is happening in the company and understand how you can help your colleagues do their jobs better, especially if you're working, for example, if you're working at a SaaS company, right, so software as a service company, web technologies is what you sell, or front end, back end, or your web application is what you sell. So if you don't understand what is happening there, how are you going to contribute? For example, if you work at a company like Facebook, I mean, Facebook is huge right now, but if you go back to the Facebook that initially started, it is essentially a software as a service, right? They're selling you a software, and everything happens through the web. And how do these technologies work? How do they interact with each other? If you have an idea, then you're likely to contribute better thoughts, better opportunities are likely to come your way as a data scientist as well. So I would recommend you to get an idea on how APIs work, how microservices are structured. You don't need to know in detail, but at least you need to know how to build basic microservices or APIs, because of the way you want to deploy your data models as well. We'll come to that at the end, but then this will help you productionize your model better. I think I've covered most of the tools that data scientists interact with. I don't know if I've missed out on something here. Of course, as you go further into each language, there are different libraries. Like Python has TensorFlow, Scikit-learn, we have PyTorch, Pandas, NumPy. So there are different libraries for different purposes. Like, but we will see through that each purpose of, or rather each functionality that a data scientist performs as we go further. So let's go. And yeah, so this is what I wanted to get to next. So now that I'm taking you through the journey of how you get started, right? You get started without knowing anything, and then you get to know what things you need to learn. Then you get to know what is a data scientist, and then now you know what tools you can work with as a data scientist. So you have some idea on what languages you need and what databases you can use and all that. So you've reached this stage now, and now maybe at this point of time, let's say you've built some projects as well because you know the tooling and all of that, and now you've started applying for jobs, and let's say you interview everywhere and get rejected, because that is what usually happens. So yeah, you start interviewing, you start getting rejected, and start getting dejected as well. But somewhere, someplace likes your resume and likes the way you work and hires you, and then you're really happy about getting hired. I mean, now I'm just talking about you working as a data scientist for the first time. You're really happy about that. And now what, right? You've been working on your personal projects, and that's something that you've been doing to learn how to build a project. But what after that is something that you hadn't thought. So this is what I'm going to talk about next. Like, once you start working in a company, what essentially can you do to organize your projects, or to make your projects more formal, to organize even your thoughts that way? Like, how do you actually go about building your projects in a systematic manner? So there are multiple frameworks that allow you to do this. There's a lot of people who have thought out about what could be the best practices of organizing a data project. And one of the earliest frameworks was CRISP-DM, as you can see on the screen, cross-industry process for data mining. And this is, in fact, it is so old that data science was called data mining back then. So you can probably guess how old this process is. But then it works, right? At least in my opinion, it still works because it has created a very good level of abstractions between different fields, between different subsections of a project. So let me just let me just read through what is there on in the cycle, and we'll go through each of this step in detail so that everybody gets an idea of essentially what it is that happens in a project. So you start off with, on the left top, business understanding, and then you go to data understanding, go to data preparation, go to modeling. I'm just going one path right now: modeling, evaluation, deployment. So if you look at this, you have been following just one arrow, right? If you see business understanding to data understanding, data preparation to modeling to evaluation to deployment, I've just followed one path. But almost always, all data science projects don't function this way. There is some amount of going back and forth between steps. And if you actually see, we've actually put arrows from data understanding to business understanding and from modeling to data preparation as well. So there is a lot of back and forth happening between these steps, because a lot of data projects start off undefined, and you're essentially trying to find a way of how can you actually define a project, how can you actually build something out of this. So maybe you have an initial hypothesis, and then you go start looking into the data, and you see that, hey, that hypothesis is something that you can't work with for long, or it doesn't hold actually the way it should. So you go back to your business understanding phase, and then you change that. So this is an overview. This is how it works. We'll start looking into each of this in depth over the next slides, so that we get a good idea of what is happening. But I'll just read through it once again, so that it goes, so that I can reiterate that business understanding happens, and then data understanding happens, data preparation comes in, modeling, you do model evaluation, and then you deploy the model. So this is the entire cycle. Let's go ahead. Business understanding. So this is a comic that I created to help explain a typical situation that I already talked about earlier. Your boss comes to you. So the first stage of business understanding is to determine business objectives. Your boss will come to you and say, hey, we need to make a customer complaint management system to automatically classify complaints to the right department. So this is the sort of problem statement that is given to you. Uh, he doesn't know, I mean, now he might know about data, he might not know about data, but here's the problem that he's having in his business, and that is that there are a lot of customer complaints that are coming in, and he doesn't know what to do with them. And he comes to you and he's like, hey, we need something to automatically be able to manage them. In fact, here the language is a bit more uh, precise. In general, it's a lot more vague, right? Like, hey, I am getting overflooded with different customers. I don't know what to do. Tell me what to do. It's more like that. Here, the boss has actually narrowed down and said, hey, we need to be able to classify complaints to the right department. You are holding a drink in your hand because that's what data scientists do. No, you're holding. That's just a comment. You say, all right, and then that's you trying to see what is the business objective that you're trying to solve. The next stage is to assess situation and determine data process goals. So, boss comes to you and says, you have 6 months to develop this. This will be used internally for our teams and will help improve their productivity. This is a lie. You don't have 6 months. You have 2 or 3 months. I mean, almost all projects start off. I mean, 6 months is something. It's a long cycle, I would say. Nowadays, people typically don't wait for 6 months for a project to develop unless it really warrants that much amount of time. Unless that is the case. So yeah, and then you reply to your boss, sure, I'll research into the possible ways of doing this and give my estimates in a few days. Again, in the very cool manner that you replied earlier as well. So this is you basically trying to see, okay, what are the timelines? How long will it take for you? How long will it take for this? Again, this is an estimate right now, and this is one of the most, I think, the one of the biggest, most difficult tasks uh, in software development in general is to give estimates, right? Because estimates right at the start of the project, you don't know what's going to happen, and your manager is like, tell me how much time this is going to take. And that is really hard because you've not looked into the data, you've not looked into the interdependencies of that project, and you're supposed to give an estimate. So this is one of the hardest tasks to do as well. I mean, not a lot of people talk about estimating the amount of work or amount of time it takes to do something, but it is hard. In my opinion, I don't know if other people find it easy. Produce project plan. So after you've looked into the requirement, thought about it, you'll be like, hey, I've made a plan with all the expected resources and time constraints. Please have a look. And the boss says, sure, I will. So this is you going through the entire process of trying to understand the requirements from a business perspective and trying to formulate a plan about, hey, what can we do next? Let's move on. So now that you've understood the business, at least the initial requirement, what you start doing is start looking into the data. How can you actually go ahead and build it? So the first step is to collect initial data. So your boss comes, hey, have you started collecting data? And you're like, cool as ever. Yes, I've spoken to our customer care teams, and they're assigning a person each from their teams to label the data. So you're like, okay, I've started the work of getting the data from our customer care teams. So start off with looking into the data, start off with collecting initial data, and then you start describing and exploring the data, because now is when you start building the project, right? So boss asks you, good, can you tell me more about it? And then you, sure, the data has these many columns and these many rows, and these many people have submitted complaints, and these are the kind of complaints that are coming in. These are the things that we are tracking. These are the things that we should be tracking, and all of these things are something that you can describe and explore. While doing that, the next part is, if you see, verify data quality. So how good is the data for our purpose is the question the boss asks. Pretty good. It covers all the departments we have. This is one way of looking at it. Another way of answering this is like, hey, this has enough data for us to be able to build a model. Maybe we don't have, a lot of times in the real world, you have junk data or missing data or wrong understanding of the data. So how can you solve this? So data quality becomes really important in that aspect. So this is where you do a thorough understanding of, okay, this is your business requirement. I've understood your business requirement, and now I'm going to go ahead and collect the required data for solving that problem. And while I collect the required data, I'm going to look into the data and explore it deeply so that I can be able to formulate hypotheses and also understand what are the things that are missing so that we can get those added. If there's any data source that is something that we missing, that we can collate and then add to our thing. So basically, you're thinking more in terms of, to solve this problem, what is the data that I need, and is the data that I have good enough? So checking for the quality, and if not, what should I do? So this is what you do in data understanding. And like I said, after you, let's say you go back to your boss and say that, hey, I don't have enough data to solve this problem. So what should you do next? You cannot solve the problem if you don't have the data, correct? So you should start collecting the data, or you should say, hey, this problem statement cannot be solved right now. Maybe we can solve an alternate problem statement, and then your business understanding of the problem state changes. So this is where I was talking about the back and forth happens, and this is crucial, right? This, if you don't do these two steps, uh, your modeling is not going to work. The modeling is talked about a lot everywhere, but essentially it is this: garbage in, garbage out, right? If you feed garbage to your model, it will spit out garbage predictions. So that's why this step is very important. And the next step, let's go into the next step, which is data preparation, right? After you've seen what is there, now you start preparing the data for your modeling. And you say, how do you select the relevant data? What are the steps performed to clean the data? How do you convert your data into numbers? It's basically vectorize your data, because your machine learning model usually accepts only numbers. So you ask these questions. You ask these questions to yourself, you ask these questions to your boss, and then you say, hey, what should I do? What should I do to select relevant data? How can I clean the data? When I say clean data, it might mean removing null values or imputing missing values, or or just removing junk values, or punctuations. Uh, if you're working with text data, uh, how do you remove duplicates? How do you lowercase everything? How do you remove stop words? All of that, right? So let's move on. Modeling. Once you have your data ready, now that you've done all the checks, sanity checks on quality, on all the required features, you've done your feature engineering and everything. So I didn't talk about feature engineering. Feature engineering is essentially you trying to come up with different features that are likely to be a predictor of the problem we are trying to solve. Let's say in our case, the problem we are trying to solve is the automatic classification of customer complaints, right? So how do I come up with different features that are going to solve this problem? So that is the feature engineering part, which is a part of your data preparation. And once you have your data prepared, like now you've converted all of your data into numbers that can be fed into a model. Now you have different problems. Your problem is now, how do I select a model? What kind of model should I select? Should I select a decision tree? Should I random forest? All these are different kinds of models that you could select. And the answer to this question is not straightforward. The answer to this question is, it depends on the size, quality, and nature of the data. It depends on what you want to do with your data. Depends on how the math of the algorithm was translated into instructions for the computer you're using. Depends on how much time you have. This, like I said, you're always running short of time because you have your deadlines that you have to meet. And how do you deliver something which gives a good enough performance in a short period of time? Uh, Even the most experienced data scientists cannot tell which algorithm will perform best before trying them. So I'm not saying all of this. All of these is something that Microsoft Azure has put up on their website. You can go and check. So this is something that I found while reading their documentation, and I found this very interesting. So I found this very interesting on their thoughts on modeling. So I said, okay, maybe I can share this with everybody, where they say that modeling is not straightforward. It is dependent on a lot of different things like your size, quality, nature. All of that contributes to your decisions about the models that you want to select. So this is in short about modeling. Modeling is a huge topic in itself. We can like deep dive into all of these different algorithms and understand what are the best practices, what are the hyperparameters, X, Y, Z, all the different things. We are not going to do that now. Let's move on. So this is what you do. So after this, you have created a model. Yeah, after this, you have created a model that is ready. How do you know if your model is performing well? So you have essentially what you do initially. I didn't talk about that, but what you do initially is you divide your data set into training set and testing set. In some places, training set, testing set, and validation set. So three different sets. Training set is the set you use. Now I'm just going to consider two for now, just to make it quicker because we are also running out of time. So we have a training set, we have a testing set. A training set is the data you use to train your model, and your model learns from your training data. Your testing set is the data that you use to test your model, and your model tries to predict on your testing set. So there are different ways of evaluating that. So if you look at the slide, it says we have a lot of different kinds of metrics. So quantitative metric could be accuracy. Like you might say my model is 80% accurate or 90% accurate, which essentially means 90% of the classifications it makes are correct. Now, there are a lot of nuances to this. Like if you have an imbalanced data set, then there are a lot of other problems that are associated with looking at accuracy, but we are not going to get into that. There are different metrics like precision, which is basically telling the number of positive, true positives that number of uh, true positives that are retrieved from the positive class. And recall, which is how good is your model in getting the different kinds of records. F1 score is a metric that combines both precision and recall. So these are, so these are some of the quantitative metrics that you can track. There are a lot of other quantitative metrics as well. There's ROC curve, ROC AUC curve that people look at. There are lift charts and there are gain charts and all of these things that people look at to track how their model is performing. Qualitative metrics, this is sometimes required, especially in the case of unsupervised learning. You don't have a quantitative metric to track, so people would essentially give it to some human evaluators. There are 10 evaluators, and then maybe you just say that I'm going to take a majority vote of the best evaluation there. So that is one way of evaluating. This is not quantitative, this is qualitative. This depends on the human that you're hiring to do the evaluation for you. Business metrics, these are the measures that are very important to the business. And let's say you build a model and you're trying to see how many people are leaving the company, churn basically, and your model is actually predicting less churn than there actually is shown in the records, then your model is not good enough from business standpoint. Maybe your training set, testing set was working absolutely fine. It showed you good accuracy, precision, recall. But if your churn rate predictions are not actually representing what is happening in the organization, then that essentially means there is some problem either with your modeling or with your data. Essentially, more often with your data. But your business metrics are something that you can track and see if your model is performing well or not. Deployment, once your model is ready, you've gone through the entire step, you have a lot of options of how you can deploy. Like I said earlier, building an API is important for you to know, and essentially what you can do is build out the predictions of your model as an API to the front end teams or the back end teams to consume, and then they can just integrate that in the web app. So that is one way. Some people also are, I mean, some of the outputs are just numbers that people want to see, and these go into reports or dashboards. And some of them are essentially action items, right? Like if you're doing it in marketing, if you're in marketing, and if you have to identify different segments, and you say, okay, these are the different segments that my model has identified, the marketing team can essentially send a marketing message to all these different segments based on your identification. So that is the action item that you directly give. It's not a product where people are interacting, but your product itself is a list of people in different segments. So this is another way you can deploy your model findings. So yeah, moving on. Team dynamics, let's just go quickly over this. This is after you've started building projects, you've done a lot of work in the field already. Now you are looking to build a team, right? Now you become a manager. Now you're become a manager. Now you're looking to see what is the kind of team that I want to build. And this is something that I think from my experience is true, that you need to build a team with varying skill sets. And if you see the kind of data scientists that come out in the market, they, like I said, it's an interdisciplinary field. You will get people with different backgrounds and different strengths. You have, as a data science manager or somebody who's looking to build a team, you have to be able to build a team that combines the strengths of each, and basically together as a team you become strong that way. So some of the data scientists will be very strong at their math, some will be strong at programming, some at a particular domain, some at effective communication, because especially if you're in a big company, one of the key things is for you to be able to effectively communicate your findings with key stakeholders, and that is in itself a lot of work. So, and some people are really good at that as well, right? They are able to translate your results and communicate that really well. But some people are not able to do that really well. Instead, they might be really good at uh, programming something really quickly or going deep into the workings of an algorithm. So there are different skill sets that each person brings. Build a team that has a combination of all of these, so that allows you to be strong in all areas rather than building a unidirectional team. Now, this advice is not common for everybody. I mean, this advice might not work if you are working in, let's say, Google Brain or DeepMind, right? Because then you are essentially just doing one thing, which is research, and then you don't need a lot of variance there. But in traditional business related in businesses, right, in general businesses, you need a lot of different skill sets put together. Let's go on and take a few question answers. I think one or two question answers is all the time we
Yes,
have.
it's right. So we have a couple of minutes. So quickly from the audience side, and thanks, Imaad, for this insightful and informational session.
Sure, thank you, Swhoami, for having me.
So audience, quickly, I see audience were having issues in seeing the videos. Not a problem. We'll share the link. You can have a look later. Anything quickly regarding you have to discuss? You can just raise your hand. We can unmute yourself. Adarsha, Pratik, anything from the audience side?
No, Swhoami.
Okay, all right. Okay, that was great, Imaad. Maybe one quick question. What I generally see asking people is that as a data scientist, they quickly very much struggle in finding what tool they use on a research. Say they have TensorFlow, on the other side they have PyTorch, right? And they, you see in the industry there are lots of different researchers, like Google promotes TensorFlow, whereas Facebook and OpenAI promotes PyTorch. So how do you see balancing as an individual which tool prefers?
I think that is a matter of personal preference as well. There, I mean, two or three things, right? One is which tool are you comfortable with? What is the scope of your project? And which tool is your company comfortable with? This is something that is also important to see, right? So because you want to be like, let's say again, the team dynamics come into play. You say three data scientists are comfortable with TensorFlow and one is comfortable with PyTorch, or the other way around. And how do you reconcile them? You need to be building together. It's not the other way around. So yeah, it's a combination of all these factors. But most of it, I mean, personally, you can do whatever you want. But when you're working professionally, you have to look at all these things.
Right. So ideally, one should know both frameworks and which is the better fit for the requirement and the solution they are making.
Sure.
Right. Okay. That's good. So I think with this we can close our this session, and I would like to thank all the organizer and of course the speaker for making it happen and sharing their valuable insights for the time they have. So till then, goodbye and see you all next time. Hope you enjoyed the session. And one request, you will be getting feedback from deeplearning.ai team. So you can just quickly revert back with the feedback. So to the limited members, we will be sharing the coupons so you can have access to the deep learning courses on Coursera. Okay. So till then, goodbye. See you again next time. Thanks for joining.
Thank you, guys. Bye.
Thank you everyone.